Good morning, everyone. This is Bijoy Mr. So we have this brain seminar today. We are presenting a model. So before we start, our friend, leader, Dr. Bella Kosaras, he's a Hungarian neuroscientist, has been in US for more than 30 years, and part of the Harvard Medical School. So he will introduce the topic. Then I will present the model. Then we'll have discussion. Feel free to comment, and hopefully we can finish in about 90 minutes. Bella Kosaras.
Good morning, good evening, everybody. Welcome to our seminar. It is my honor to introduce you shortly. Our speaker today is Dr. Bijoy Mishra. Many of you know him very well. He is a physicist, astrophysicist, and enthusiastic about the brain. I met him in our group in Harvard when we work on creating a high-resolution RMD 3D mouse brain atlas, we needed a computer imaging expert. So Dr. Richard Sidman, our leader, found him teaching computer imaging at the Harvard Extension School. He invited him to work with us as a consultant and helper to create excellent images to our planned mouse brain atlas. During the work, which was finished successfully, Dr. Mishra had got amazed and enthusiastic about the brain, as seeing many neurons in the stained histological sections. Maybe it wasn't the first even that he was interested in the brain and its function, how it works, but probably this joint work was a significant impulse on him that after a couple of years, he established a group by inviting people who were also interested in the brain function and to discuss and exchange views and extend our knowledge of the brain function with a particular focus on the auditory system. How does the brain create speech? So our topic was mostly in the auditory system, how the sounds convey to the brain, and how the brain with different areas elaborate, sparse the incoming information and create a word, and then order the vocal system to express it as a speech. As Dr. Mishra is with an astrophysicist background, always played with the question how the brain function can be connected to the cosmological view of the universe, to the general rule of the nature. So he is going to present his view on this topic. Dr. Mishra, now the pulpit is yours. Please entertain us. Thank you.
We'll try to elaborate or maybe explain a model. This model, I'm giving you a brief chronology, how the model came to be. So I'm saying an attempt to create a first principle computational model, human brain, regard the cognition and speech. What is cognition? How we comprehend object. And then speech is how you convert your cognition to expression. So we'll try to see. So now it's a cosmological model. Cosmological model, not because I have an interest in cosmology. Cosmological model because we figured out, or I figured out, that brain is not somewhere there. Brain is a part of the universe. Human brain is an entity where we understand the universe. So it is not a tool. It is the brain. It is the human defense. It is the human understanding. It is the human mapping. So that we shall see how we can model it. I'm giving a little technology here. So we had a language table. We started in 2010. So here these people, Jamnabai Prakash, Chandramouli Subramaniam, Jaspal Singh, Hardeep Man, Paul Meixler, and myself. We had like every Saturday we met for many years. The logic was to distinguish between is speech an expression or speech something that you hear. Um, so then we had also running a Sanskrit table in Harvard. So Thomas Burke, who has passed away, and R. Balachandra, who is a professor in Northeastern University. So they would be talking about grammar in Harvard. So gradually we moved forward. We tried to prepare a paper. We went to Bangkok, myself and Prem Nagar here. So we went to Bangkok to present a paper. So Bela, myself, Prem, Jashpal, Hardeep, so they contributed paper. And I'm also writing Sesadri, Ramaswamy in MIT, Demna Patnaik, my friend, old friend from college. So we were put together like how words are created. Um, and so we had three papers, 2018, 2021. Professor Ashok Akluchkar, he became a friend. He became a friend through this World Sanskrit Conference, but also he had visited Harvard in 2000, where he influenced me to think about Sanskrit words. Then I have to thank our friend B. Ramapriya. He and we have been doing the Vedas for last 8 years now. We had a session yesterday where we read the Vedas and understand the syllable. The whole point of the exercise is whether the syllable has a meaning. When we say something, express something, that's the phonetic constant. So phonetic constant means it may be used differently, but the quantized information through the phoneme. Um, so a brain neurology group became active 2020. Bela has been active much before, but we became formally to work on the speech. So Bela, myself, and Prem, we went on having monthly meetings. Then there's a bright person, Bharani Padmanabhan. He's a MD PhD from Hungary. He joined 2023. So we have a brain research group. And then Dr. B.V.K. Sastry from India, Shivaram Subramanian, who is here, Avijit Mandal is a professor in India. So they join occasionally. And I have been grateful with the Subramanian Kurada from Hyderabad. So this is my acknowledgement. Now, let us go to the model. So the model assumptions. So as I said, we have a first principle model. What is first principle? That is, you don't really assume anything what is not needed. So first assumption is cosmological unit. Cosmological unit being what we'll say is as the evolution takes place, to Darwin does evolution. So plants, animals, and birds, things happen, monkey happen, and man happens. But in the process, the man develops brain. So that's the substantial process. It's not the monkey became man. Monkey became an understanding man, a brainy man. So that is the cosmology of brain. That is the whole universe came to the brain. And I'll say how I see that might have come. So which basically means that in the evolution span, there's a period where the man's brain is developed and brain is trying to understand the universe. I call it a comprehension stage. And we can't say how much time it might have taken, but we believe, or I believe, that such a thing probably happened to really use the brain and make the brain as we know of. So then we are saying that there's subjective intentionality in the brain. This is not necessary, but I think it happens. What that means is that all the universe information may not enter you. You may have an aptitude. Who develops the aptitude? Genetics, your own setup, environment, we can't say. But what we would say is that you take the fragment, if fraction of the universe inside of you, and you comprehend it. And I will show later that comprehension as a process is self-complete. It doesn't matter whether you take a fraction or a large. So comprehension has no quality. Either you comprehend or you don't comprehend. We'll come to that. Number third assumption, the brain has the capacity to portray all stimuli in distinguishable expressions. This is, I was telling before, informally, that we have this um, body, voice. So we're endowed with this degrees of freedom, latitude, so that universe can be expressed through us by muscles, by vessels, by voice, tonality, frequency, um, and then maybe airflow or breathing, so various ways. So the assumption is that the information that gets into us, we have the capacity to express it back. It goes from the scriptures in India and so on, but I don't want to get into it. I want to make an assumption that that's true. And then I'm saying the brain has the built-in faculty of imagination and imitation. There are two different things which will be very necessary for our development. So cosmology of the sense objects. So this is something which I am asserting in the sense at the present time, what is assumed is that as I am seeing the screen, so as the screen is being mapped inside of me. So which basically means the screen has this rectangular size and this two-tone plastic glass. So it kind of tries to, what I am advocating or asserting, that it is cosmological. What is cosmological? That is, the brain has these modalities. We have 5 modalities: hearing, touching, seeing, tasting, and smelling. You have it. So those 5 modalities receive information. That is the only way you can receive information. So information from the object, whatever is kind of talking to me, I'm sensing, is coming through these modalities. So basically what I can do is any object in space, in the universe, I can represent in a 5-vector space, a cosmological vector space, space, air, fire, water, and clay. So this is the original cosmology now tuned to the sensory modalities. So what happens is, so this object, which is like I put a star here, an object. So this object, it has like five different components: a space component, an air component, a fire component, water component, and clay component. So basically, all objects in the universe are a point in this five vector orthogonal space. And then the object carries this property with it. So depending upon how the object forms, the object carries the property with it. So table is an object there, but I will say why table is an artificial object. So natural objects, mountains, trees, forests, rivers. So cosmological, then I'm saying that the different vectors have their properties. The space has a volume property, air has a texture and temperature property, fire, radiance, and color. Water has solubility, test, and potency, fluidity, friction, odor for clay. Now, these are all should be quantifiable in the sense that you have a computer model, how space presents itself in the object, how air presents itself in the object. So we will come to that. The computationally, the brain understands so much of space, so much of air, so much of fire, so much of water, so, so every object. So all that information entering the object becomes a neural map. So basically, the object from the universe, object is sensed by sensing modalities. It is represented by neural map. So basically, what happens is that the object has become a neural map through this, as is inside the modality, has come in, and the modality, the information is tagged by the modality in the sense where it came from. So the information, space information, air information, fire information, water information, clay information, the amount of it as received by different senses. So they have tagged into the modality. So each component of the object is mapped by one or more neurons depending on the attribute. Uh, Whether it is one or many is not a function of size of the object, function of the attribute of the object. How much of information you need on that object from that vector. So that will probably determine how many neurons you need to use. Neurons are distributed through the cortex. This is like anatomy, where the neurons are, subcortex. So why? Because the information, the sensing information, has to be transferred in some kind of a quick way. So each map, so we will call a technical word called concept now. So concept is a neural concept. So basically the object from the universe has become a neural concept. So mountain is not there anymore. Mountain is a neural map, a concept. So all these neural concepts have they have no Cartesian space-time context. So they are neural maps. So it doesn't say where it came from, what size, the Cartesian in the sense, where you saw it, what kind of geography it has. So brain doesn't care. This is the model. This is how I proceed on it. So I give an example of a concept registration. So a concept, this is like a mock picture of neural map. So what I'm saying is that this is how a concept will show up in the brain. So these are different cells and they carry different attributes, but all of them become a concept. So, so now affinity of concept, concept class. So concepts also make a class. What is class? So in the cosmology or in the nature, so objects have the binding in the sense that the trees are near the coast, the water is in the sea, so they have a kind of association. So even though water is a concept and ocean is a concept, so they kind of association. So basically you have a concept class. This is a computer term in the sense you're creating a class of objects. So brain decomposes a scene to make object cognition, but it knows the object is a part of a scene, tree and forest. So the class happens. So basically what happens is the neural structures, even though they could be distributed, but they could be a part of a class. So like, you know, uh, so that class or boundary of the object is determined by the brain, and we might create some artificial boundaries, but we might have to also go into the natural boundaries. That is, when does the tree become a forest? How many trees? The scene can be a concept cluster. The object cluster is linked to the scene cluster. So there's so concept, object becomes a concept. So concept has a concept class. Now concept class can be cluster. Uh, then we bring this new concept called preposition. This is a basic idea that we see, and we don't know how the brain operates on it. But it seems like the way they are using it, probably the brain has built in these prepositions. What a preposition? That is, as the concepts gather up in the brain, so the concepts are linked to each other. The concepts are not separate. So concepts are linked to each other through prepositions. And the prepositions are 20 in number through the Vedas, but could be more, we do not know. But basically what happens is they're built in. There's a human constant. That is, these are the tools the brain has, some primitive neural chains, which would be used to binding the concepts. So the brain together, entire brain is linked. So a concept not separate from that concept. So those are the prepositions. So I'm giving us some kind of mock picture again. Um, so preposition clusters. So I'm giving you some kind of a preposition cluster, but these are again mock in the sense, basically you are connecting a concept, another concept. Preposition clusters, neural links are transients. Why transients? Because they are not there all the time. They only come as needed. In a sense, you can operate with one concept completely until you need the ocean. Forest can operate. The ocean comes. So then you have a link. That's the preposition. So now these transient links are the modern neurology discoveries. So grammarian Panini notes 20 prepositions. Some preposition may act as adjectives, which is like a concept can be expanded. So we shall see whether we don't need them, because in the neural field, adjective is not required. Adjective is a linguistic term. So the neural energy is equipartisan, same for all neural concepts. Preposition can connect to verbs, and I'll come to that. Paninian preposition mapped as flexible neural clusters. So I come to neural tags now, and this is important, and people who are in the field thinking about it. Now you have to kind of understand that huge amount of empirical, experimental work goes into this. So a neural tag, so basically what we are saying is we have a expressive mode. So expressive mode in this concept that comes in. So the assumption, as I said before, so the concept that you create, so that concept can now be expressed. So we are saying expression is a pupil dilation, skin folding, muscle tension, blood rate, air rate, increase rate in breathing. So those happens mechanically. But more interestingly, happens in the expression of speech, that you can express it. So that expression, so mountain doesn't become a mountain. So mountain becomes a sound. So when mountain becomes a sound, so mountain's information as stored in the neurons is transferred to the vocal energy, and voice manifests it. So we are saying that process is done through our pattern of speaking. So Sanskrit and Vedas and the Paninian grammar, they talk about 64 syllables, but we have to find out from the degrees of freedom and the process of breathing and the different operators we have, like a tongue, teeth, lips. So how many such syllables are possible? This is a vast subject. The tonality is large, but the assumption, as I had said before, that assumption is that thy can express. Now, whether you can express completely, probably is doubtful. Why doubtful? Because syllables are quantized. Syllables are not analog. So the conceptual information that came from the universe is analog. And now you have to reduce them to your breathing. So anyway, so I give little statements here about how many syllables are there. This I talked in the last year, a similar talk, but we compute them. We assign degrees of freedom to each organ speech, calculate the frequency of expression, each independent signature is a neural tag. So the question is, we just produce these neural tags, which are the human syllables, and we don't know the tag duration that we compute. So we have to give a metric that this we'll call a tag. So that tag, so many tags will describe an object being a concept. Concepts are mapped neural tags. A tag representation concept achieved computationally. So here is a concept neural cluster, and I'm giving some kind of frequency map which we produced here for a paper we presented in 2018. So these are the as you can see, that the different intensities, frequency intensities are lower, and the frequency variations are there. So each is now, the question is whether a tag is represented. See, where we said those, we use the Paninian syllables. but they may not be the ultimate syllable. But this is an idea that we have to create a neural tag for each concept. As I said before, each concept is a natural object: space, sky, clouds, sun, stars, uh, observable in nature. So they are the objects. And so those objects, and also like whatever artificial you are hearing, but I'll come to the artificial objects a little later. Here we're talking about the comprehension as cosmologically coming to you. Um, so on the left, there's a neural cluster, and each of these things has this vibration. And this vibration only one dimensional here in frequency, but it has also a tone, um, which we could not measure, but we compute. That's the idea of the computational model. So then what happens is that these tags, when we operate, then you find that these oscillations are inherent in the brain. So this is a new finding the last 30 years or so. So the brain, if you go make the measurements over the scalp with electrodes, so people find these waves, delta waves, theta waves, alpha waves, but different frequencies, starting from very low frequency, 1 to 4 hertz, to very high frequency, 30 to 150, which are the ways in which brain registers stimulus. So the connection is to think whether the mountain became a neuron by cognition when brain registered it. Now, what I'm claiming is the original registration of the comprehension. As I said, there was a period where comprehension was taking place of the nature. So those are primitive neurons are in the brain. That's your bodha. I will come to that. So that is your basic brain. So what happens when the new stimulus comes? So new stimulus, which is not there in the original natural brain, so that gets mapped by this oscillation to see whether it can match anything previous or what variation there can be. What the anatomists or the brain scientists have said that the oscillations are localized. Localized in the sense they don't happen, they can happen in various areas. They have the same frequency, but they can happen different areas, and they have arbitrary wavelengths. Beta and gamma oscillation connect to reading the stimulus. So these are findings from the neurology, but I want to connect them to verve. So verve, what happens is, see, the universe now has two states: a stationary state where the mountain tree, they don't move, and they can't move, but they can grow, they can decay, but they're still stationary. And then the second state is, so they are, displacement is there. So these two states, that is freestanding and stationary and moving, so we connect them to the two modes of expression that Panini has identified, which is Parashmanipadi and Atmanipadi. Why? Because when the object is stationary, you can observe the object. You can describe the object. But when the object is moving, you become conscious that whether it can come towards you. So cosmologically, these two events, which is moving, stationary, that connected to, in our mind, these two kinds of verbs, description and interaction. I call it observable and sensible. So now what happens is, so as the object is doing motion, then these oscillations kick in, and oscillation registers what that motion is. And this becomes somewhat interesting because the verb, what the action happened. So that verb becomes a quantized object. Why? That becomes, so these are the neural oscillations I'm showing on the left, um, from a paper. So you can see delta, theta, alpha, beta, gamma oscillations. So this is how the brain, the electrodes see them. And this is a power spectrum here, different kind of energies. But that's important. Important is you can see that somehow the most energy is somewhere around the alpha, um, which is like what's the 10 hertz? 10 hertz means like once in 10 cycles per second. Um, so now you can see in different periods, so different things happen. So basically, what happens is in our mind, I am also giving you example of like a simulation where in different areas of the brain you are seeing this oscillation happening. So the different verbs that Panini find 2000 verbs, about 700 Atmanepadi, 1300 Prasmepadi. So they have their origins, locations, different parts of the brain, depending upon what action the uh, verb may do. So basically, what I am suggesting or little model that you have two states now, stationary and moving, and then there's a verb. From stationary to moving, there's a verb. But verb is not registered as such. The verb is registered as a difference. So stationary is a state, and the moving has occurred. So brain registers only physical objects. So it doesn't register the action itself. So action is derived. So all the presentations are discrete, so are the verbs. So verbs are quantized. So question is, how many such quantizations are possible in the brain? So so brain registers. So what I'm saying is these oscillations that are happening in the brain, they have their equilibrium modes. So alpha, theta, gamma, and so on are they're oscillating naturally. So they have their equilibrium modes, and those modes, they may happen somewhere in the brain. And those modes are the verbs. So, so that registration we computationally show there may be more to it, but this is the hypothesis that the brain has this verb quantized. So, so I'm saying number 4 here, Panini's verbs are representations, acoustic signatures. So we map these signatures and neural tags, compute the equilibrium modes of the brain oscillations, comparing the neural tags in the step 4, which is here, Panini's verbs. We locate the cortical areas that cause the verb to register, not cause the verb to register. So Atmanepadi verbs would exhibit the connection to the motor cortex. So that's the idea. Idea is that there are quantized verbs in the brain which can be determined by the equilibrium mode. So here I'm giving the basic brain layer. This is the comprehension layer, cosmic elements. So we have these selection rules in the sense how the object will be created. Even though we have a 5-vector space, so there are, so these selection rules are from basic physics. There are Indian sciences called philosophical sciences by Shishika, that what can happen, who can take. So those have to be added there. Um, and also some chemistry, that what can form, what cannot form. But anyway, once it forms, they become objects in the universe. So then the stationary and motion, the two different things. So then there's the sensing. And in the sensing, some timestamp we add for the sake of registration is not required, but most likely some kind of a stamp comes in for the memory. And this timestamp then begins the oscillations in the brain. So oscillations lead to verbs, prepositions, cognitive concepts. Uh, so the oscillation play a big role. Neural clusters, neural classes, neural tags. So I want to impress this neural tags that comes through the base layer comprehension, that is there inside of us, all of us, is a basic layer of comprehension. Comprehension has no speech. Comprehension only has tags, has an understanding. When suppose you are comprehending what I'm saying, you are not expressing anything. It is inside of you. So various neural bundles are operating, which are blossoming, and they help you to comprehend. So it's a physical process. So brain state of comprehension, we postulate the developing comprehension was the evolution time step for the human species. Selective registration of objects, understanding their basic relationship, fundamental. So this is what comprehension, what we are saying, develop the human intellect, and in Indian literature called buddhi. Buddhi is not intelligence. Buddhi is your understanding, your comprehension. So that's neural. So this is the brain base layer. Comprehension doesn't have a time component. All recordings are present. What is present? So it is not when did you see a mountain or when did you see a tree. So these natural objects inside of you, they're always present. They have no history. Comprehended objects are tagged internally with neural tags, prepositions, and verbs. So there is a concept-verb association inside of you. You understand it. But what I'm claiming is comprehension is not comprehension is not verbal. Comprehension internal. Concepts are neuter, individual, and equipartitioned. So these are kind of little loaded words, but what that basically means is each concept is equipartitioned. Amount of energy required to create a concept is independent of the object. It's a neural inside of you, thermodynamic. So we have, as then I said before, we have this faculty of imagination. So what we have done is we have, through comprehension, we have created concepts of nature and we have created neural tags of nature. So that's the base layer. So that's your own solitude. Individual is in its own primary operation, where the universe is comprehended as such. Universe is taken in the present. So that's your comprehensive. But what you have done is, through your body energy, airflow, your expression capacity, you have created the neural tags which are connected to these objects. And you have created also verbs for the nature. So now what happens is, through imagination, what you can do, which you probably do, that you mismatch. So the tree is not really a static tree anymore. Or imagine what happens if the tree moves, or what happens if this mountain is not there. So imagination. So that's a faculty. So now how many neurons operate in imagination, we have to figure out. But what I'm claiming is that this organ, degree of freedom, or organs of speech, so that created speech phonemes and neural tags. So then the concept became pattern matched. And so we have a now, instead of regular clusters of concept, you have tagged neural clusters. So you have a different layer altogether operating in the brain, which are functions of the tags. Tags were associated with the concepts, but now tags are the concepts. So you are not getting to the concepts, you're operating with the tags alone. So those tags have preposition, those tags, these are all acoustic forms. So the earlier verb was a neural cluster, which was kind of giving you the perception of the whole action. Now it is only an acoustic verb, so you just state it, you don't fully comprehend the action, preposition, verbs. So this will lead to creation of sentence. In the comprehension stage, there is no sentence. There is only objects. But now you have imagining that this is how it operates. You are using the timestamps to create some history. So grammar, tone, and melody. Um, and so sentence, and this is how the Vedas come to be. So what I'm saying is, the comprehension stage has no language. The full understanding. Things are present. You understand them, a solitary state. But in imaginary state, you are giving acoustic signatures to objects inside of you. And then when you are expressing them, they become literature. So some of the very early literature with the Vedas, and then other literatures can come, composed sentence, composed words, composed literature. So that's the, and so again, so that's a basic layer of comprehension, and there's the imaginary layer of tagged. So basically, you are creating a tagged universe, a semantic universe inside of you, which is natural, but it is not, you are not comprehending it. You are simply using the tag. So, what I'm saying is, words, communication, grammar, concept neural tags can be remapped as acoustic objects. This is what I said. We postulate that these utterances in early evolutionary history created the acoustic signatures for objects. So we would know how the neural tags are making the objects, computing them. As I said, those frequency plots and so on, there'll be a large number of them. So we deduce that early spoken language evolution had only object signatures, nouns and verbs. This again, a way of looking back how man must have started speaking. So nouns, objects are there, and verbs seem to come, transients. So the man may say, this happens. So some of the old languages have this kind of structure, primitive. Comprehended objects are tagged internally with the neural stacks, prepositions, and verbs. Simple sentences are produced without any word order because you are putting neural clusters in play. All right. And each neural cluster is complete by itself. Semantics develop through articulation. Acoustic signatures cause emotion. This again important. In the comprehension stage, there is no emotion. You are with the nature. So there is no variation. So now you can say emotion. Emotion is a brain property, but you trigger it. You trigger it through neural tags by virtue of expressing it differently through your voice variation, articulation, you create emotion. And so basically what happens is the semantic universe in the brain becomes a new quantity, a new set of neurons which are semantic in concept. So grammar and communication develop in the imaginary layer. So then I have a tertiary layer. Tertiary layer is imitation. This is something we have borrowed from the animals. That is, and this is where the language is at the present time. In the sense, language has to be taught. So we see the word speaking, and so we speak. So imitation. So as I say, you should say, this is how you twist. So this also is there in the human brain that you can imitate. And I'm told, Prem told me the other day, there are some mirror neurons are active to help you imitate. But what I see in the model, that comprehension, imagination, and imitation are three different layers. So imitation, what happens is the objects are there, objects and actions and prepositions. I'm putting this color symbols in the sense, this so-called purple, that's natural. Uh, but then I have artificial objects. Artificial objects mean they have buildings, house, means table, desk, and so on. So they are not there. They are not comprehensible because the brain doesn't relate to them as comprehended objects. Brain cannot easily decompose them into the five vector space. So it lives as a tagged object. So speech phonemes. So you call a table a speech phoneme. So table is not a conceptual neural cluster. It's a semantic cluster. So local phonemes, local grammar. So that happens. So these four lines are so natural objects, artificial objects, then actions are the verbs, prepositions. So they go through, but they make a local grammar. So local grammar in the sense you are learning the local grammar and local phonemes. So you create a semantic layer. So semantic layer has neural tags from your original comprehension. Imitation neurons are this artificial, and the neural tags for the action. Action in the sense, the verbs in the brain are from the comprehension stage. They're not changing because they are verbs in the brain and preposition in the brain. So they remain same. What changes is so a lot of imitation things are coming in as objects. So what you do is you operate your original brain framework using this artificial objects and local grammar and local phonemes to those objects. and then you create sentence, and um, and you understand and communicate. So that is where the present or the normal communication. So the three layers is a normal communication layer which has comprehension, but if you are using neural tags which have linked to the neural concept map. If they're not, you are putting more extra energy and you are in stress, entropy increases. So I'm saying that in the next, so speech, local objects, local language. So human brain has imitation neurons that adapt to external stimuli. Imitation neurons operate through semantic layer. Imitation neurons get activated on the duress. This I kind of said that how does man imitate? Why does man imitate? Uh, Whether it's natural for man to imitate. But I'm saying either duress or through controlled practice. Why controlled practice? We call it tradition, or we call it that you must learn this. So what I'm saying is the brain understands things before even you say that, call this a tree. Brain knows what a tree is. You don't have to label it a tree. So that freedom of the brain is suppressed by throwing some kind of a local terms. So arbitrary words in grammar can be imposed, which probably are. Local subjective word-oriented concept space is created. Communication possible only with the local language speakers. Now, the comprehension space is universal. There's no locality of it. Either you comprehend or you don't comprehend. It has no artificial objects. So the local language words can be arbitrary. They can have an overlap with the comprehension concept space to create literature. Here I'm saying that the literature that stands out uses the neural tags of the natural objects. So then those literature gives you happiness. Uh, Other literature can be entertaining, the local literature. The semantic layer can develop melody and music. Melody and music is in the imitation layer and in the imaginary layer, which are remnants of. See, when I said that you are creating a verb and verb oscillations may not fully match. So there would be, in order to match, in order to create the full matching, you have to expand the verb, extend it with this higher frequency harmonics, which is the melody, which we can do in the computation. So imitation layer can be suspended, inner layer can be perceived through solitude. So this is something people who meditate or understand that whether who are you, so they might probably figure out that we have these different layers, but we can reach back to the comprehension layer if we wish to, if we suspend the other layers. But when we reach the comprehension layer, we don't speak anymore. We just understand it as the universe in you. So I'm saying, so this project, we have follow-up project, what we can do. So as you can see, it's a very large operation. Multiple things are happening. So I'm saying one thing is computation of a complete set of human syllables by a couple of people, take 2 years of time probably. Basically extending the Paninian system to a biological system. So some of the syllables might not be expressed. They may be extra acoustic, but they may be expressed. They are probably expressible through um, blood flow. So you have to kind of make a total map of it and the energy consideration. Calcification of Paninian verbs into cosmological groups. So this is where our friend Avijit has started working on it, which is basically is that the Paninian verbs or the verbs thereof have been classified into how they could be uttered, not how they would be formed. So we have to have some object definition. Why does a bird fly? Why does a man run? What happens? The cosmological entity of man, the cosmological entity of bird. So then verbs associate that these objects can do this. So that association map, analyzing the brain oscillation to get equilibrium modes. So this is kind of a probably not so difficult, but we need data. I did my long time ago on my own thesis on the equilibrium modes of the Earth atmosphere. So equilibrium modes, in the sense oscillations are part of stability of any system, but then they have to need an equilibrium. Uh, so where the stability? How does the system become stable? So different frequency, there are phases, how the phases will, so I project 2 years. So connecting verbs to motor cortex, this is neurological. Mm, I think we have some information from grammar that what the verbs do. When the verbs do, they have something with the motor. So whether those motor things can be established by virtue of the map I saw before. So creating a word through neural tags, this is a little more complex because neural tags, even when we see this Vedic recitations or Vedic compositions, so they are used as words, but we don't see any way in which the human being knows any word. Human being only knows a syllable, a neural tag that can be uttered in a single breath. So you have you have quantized. So you can only have this kind of discrete information. So from there, you have to create a word, a scene, a structure. So we have to put some kind of a physics onto it because cosmologically, there is no grouping. So that is where we have to see what does it group? For example, how does the brain see, in the grammar we say we in the sense a group of people. So through the model, we don't see that the brain sees individual people. So individual people is a concept. So group is a concept, but group can't be, is also a one object. It's not a multiple people in a group. So group is an object. You follow what I'm saying? So like that. So we have to then see how the words are semantics is created from neurology by virtue of communication. So which means the communication world in which we use the groups, gender, number, so they are artificial, except brain uses them. So I'm putting 2 years for that. Then coding. Coding, I'm putting 3 years for that. So we shall see whether mm, sufficient good people. I'll code. I've started coding, but it will take time. So participation will be seeking support from National Science Foundation and Templeton Foundation to see whether we can proceed. So people who are here, many people are here, so they might connect to me, see whether we can find funding and do the work. So I want to thank a few people individually. So these are the few people who I say personal gratitude. So Chuck Whitney, my office mate in Harvard, Professor of Astronomy. He taught me that words are not trivial. So he will interpret the night sky to paintings and words and images. So we had many, many interesting conversations. And actually, introduced me to David Hubble in MIT. How does the eye see, and so on. Chuck passed away in 2017. Um, I would say he's the most powerful influence on me. I have Dick Sidman here. Bella talked about him, and he led the project of the mouse brain atlas, and invited me to collaborate. Dick is an anatomist, so I saw person who is looking inside the brain. Chuck is looking outside the brain. He is a man who is going inside the brain, but he's seeing the anatomy of the brain. He's not seeing the word in the brain. So we had a long conversation with him about where did the word come from, and he doesn't seem to be interested, but he definitely subjected me to large number of reading, understanding, which we did, and that thing is online now. Dick passed away 2 years ago. And then I have from our friend Ashok Aklujkar. Aklujkar is old now, but he's losing his mind. Some kind of a dementia has come in. But he's the one who blessed it. He came to Harvard in 2000. I had interaction with him. But when we first tried to say that speech is quantized in a paper, we'll call it Russia. So he saw the abstract and he called me that he loves it. I didn't know that he would so much love it. We didn't know what we're talking about. So, but he kind of kept the interest, kept on bugging me. Are we moving? Are we moving? Got the blessings. I had this interaction with him 2, 3 weeks ago. He's sick, but he joined with me for an hour. So Asoka Klush, he's in Vancouver, Canada. And then I have my friend here, Dr. Patnaik. Patnaik and I go back to 1969. He was a professor in Deccan College doing linguistics, and he will take me to his home. And you talk about word in the sense he was interested in the tribal speech, how I was not into tribal speech, but now I could now understand that speech is something inside of you. So these four individuals, I want to pay tribute for whatever I've learned. So with that, I conclude and we open our meeting for any questions you may have. Thank you.